Hello, today we're starting a new topic. We're looking at volume, and today we're looking at the volume of basic prisms. So the goal for today is to find the volume of these shapes here. So by the end of this video, you should be able to find the volume of a rectangular prism, a cylinder, and a triangular prism. So if that interests you, feel free to stick around and watch the video. So volume is the total 3D space an object takes up. So we measure volume using cubic units such as millimeters cubed, centimeters cubed, and meters cubed. So let's look at a cube. So this cube is 1 centimeter in every direction. So we'd say this is 1 centimeter cubed. Now, if we look at the shape on the right, it's 3 centimeters in width, 5 centimeters in length, and 2 centimeters high. So how many of these 1 centimeter cubes would fit in the shape on the right? Now you can count it for yourself, but we could fit 30 of these cubes in the shape on the right. So we'd say the shape on the right has a volume of 30 centimeters cubed because you can fit 30 1 centimeter cubes inside that shape. Now the most common type of formula you'll see for volume is a rectangular prism, and that is volume is length times width times height. For example, if you look on the left, we can see that the shape has a length of 5 centimeters, a width of 3 centimeters, and a height of 2. It's the same question we had before. So if we want to find the volume, we can simply go 5 times 3 times 2, which is 30 centimeters cubed. So you can fit 31 centimeter cubes in that shape. If we look at the shape on the right, let's do the same thing. It has a length of 7, a width of 4, and a height of 3. So 7 times 4 times 3 is 84 centimeters cubed. So you could fit 84 of those 1 centimeter cubes in that shape. So this is just a very simple formula you can use to find the volume of rectangular prisms really quickly. But I'm going to do you one better. I'm going to give you a formula that will work for any prism. Doesn't matter what the prism is, it'll work for any prism you see. So to find the volume of any prism, just find the area of the base and times it by the perpendicular height. Now when I say area of the base, I mean find the sides of the prism that match. Find the area of one of those and then times it by how long it stretches out for. It'll make a little more sense in the next diagram. Okay, let's try an example. So let's look on the left-hand side. We can see a triangular prism. Now just ask yourself, what shape is consistent all the way through a triangular prism? What shape can you see on both sides of the prism? Hopefully you'll notice it's this triangle here. So what we want to do is just find the area of this triangle. So if we find the area of this triangle, half times 3 times 4 would get 6 centimeters squared. Now all we need to ask ourselves is this area, how long does it go for? It appears to stretch out 11 centimeters this way. So to find the volume of this shape, we're just going to take the area we know and times it by how long it stretches out. This will give us 6 times 11, which is 66 centimeters cubed. And now if you look over here at the cylinder on the right, just ask yourself, what shape would we use for the base area? What shape is the same on both ends of this? Hopefully you'll realize that the circle is the same on the top and the bottom. So all we need to do is find the area of the circle and times it by how high it is. So the area of the circle is pi times 4 squared, which is 50.2655. So we just take this area here and we're going to times it by how high it is, which is 5. So if we times that by 5, we'll get 251.33 centimeters cubed. So basically, it doesn't matter what prism you have, just look for what shape is the same on both ends. Just find the area of that shape and then times it by how long it stretches out for, and you will find your volume very quickly. Now some shapes have been tipped over or on a slight slant. We call these oblique prisms. So the volume of any oblique prism will still use the exact same formula. Just find the area of the base shape that's repeated on both sides and times it by the perpendicular height. Now when we're talking about oblique shapes and perpendicular height, we're looking for the straight up height, okay? We don't want to use any slants, we want to use the straight up height. Alright, if you look at these 3 examples here, these are all oblique shapes, okay? These are all shapes that have been pushed over slightly on their side. So if we look at the first example over here, we can see that the base area of this shape is a square. Now it looks a little funny because it's on an angle, but this is a square. So to find the area of this base, we're just going to go 4 times 4 and we get 16. Now to find the volume of the shape, we're not going to use the slanted length, we're going to use the straight up height, the perpendicular height here, which is 6. So 16 times 6 will give us 96 meters cubed. For the cylinder over here, we can see that we have a circle and it's 12 centimeters high perpendicular height. So we need to use that 12 centimeters. So all we're going to do is pi times 3 squared, get our answer, and then times it by 12, and we get 339.29 centimeters cubed. Now for the shape on the right, this is a triangular prism. This length here will match the bottom 34 millimeters, and we know the height's 24 millimeters. So the triangle is going to be half times 34 times 24, which is 408. And the perpendicular height, the straight up height, is 48 millimeters. So if we times by that, we'll get 19,584 millimeters cubed. So if you ever have an oblique shape which is just tipped on its side, make sure you use the straight up height, which is what we call the perpendicular height in your calculations. Thank you so much for watching. So hopefully you found that helpful. So remember, to find the volume of any prism, just find the area of the base shape. So that's the shape that goes all the way through and is on both ends. Once you find that area, just times it by how long it goes for, and then you'll find your volume. See you guys next time.